Year 13 PPE Pure Mathematics Paper 1. First question. This is about the rules of indices. Okay, and what I would do here is express this 8 as a power of 2 and express this also as a power of 2. So I would be writing as my first line 2 to the x, okay, multiplied by 2 cubed to the power of y, and that's equal to 2 to the power of negative 3 over 2. Combine these first two terms together with a single power of x plus 3y, and that must equal 2 to the power of negative 3 over 2. And now I'm in a position just to remove the bases and just have x plus 3y equals negative 3 over 2. And if I solve that by subtracting x and dividing by 3, it gives me y equals negative 1/2 minus x over 3. And that's it. Okay. Next, a sector of a circle. We notice the angle is 40 degrees, and this student has used this working out here to get the area to be 500. Now, aside from the fact that the area clearly must be a lot less than 500, we also notice that 40 degrees has been used in the formula for the area of a sector where that's required to be in radians. So the mistake that the student has made for part A, it's only 1 mark, so it doesn't need to be a lot, but something to the effect that theta needs to be in radians. Theta needs to be in radians, not degrees. That's the obvious mistake that's been made there, or something to that effect. And then, in any case, you're going to do it correctly next for part B. And given that it's 40 degrees, just write it as 40 over 360. Okay, or 1/9 if you like, 40 over 360 of the area of a circle of radius 5, which is pi times 5 squared, and that gives you 25 pi over 9 as the area. Okay, and 25 pi over 9 could also be decimalized to give you 8.73 centimeters squared to 3 significant figures. Okay, you don't need to do that part. I think the question doesn't ask for that. It just says write out a correct solution. So you could stop just there, but I've done them both. Okay, next. Okay, we have a function that's defined in two sections. Okay, to the left of 2 and including 2 and less than 2, it's a quadratic, this here, and then from 2 above 2, it's a linear equation, y equals 4x minus 7. Okay, and we've got to find the value of g of 0. So we've got to take 0, put it into g, see what comes out. And if what comes out is less than 2, we put it back into this part. If what comes out is greater than 2, we feed it into this part here. So we need to do g of 0 first. So I'm going to put part A. Okay, let's find out what g of 0 is. Show all your working. G of 0 is equal to 0 minus 2. Okay, all squared, which is 4 plus 1 which is 5. And because 5 is greater than 2, I've got to feed that into this part now. So I then got to do g of 5. Okay, and that gives me 4 times 5 minus 7, which is 13. Okay, and because I've broken it up into 2 parts, I'm just going to say or remind the examiner that that is g of 0, like that. Okay, but that's the answer there. Now part B is asking us to find the values of x for which g of x is greater than 19. So really what we're doing here is we're imagining we've got a horizontal line crossing the y-axis at 19. Okay, and we can see that that line is going to be intersected twice by g of x, once by the quadratic part and once by the linear part. Okay, and we've got to find those solutions really and state them in some kind of inequality form. So let's start with the quadratic part. Okay, what I'm going to do is find the critical values. Okay, because we need to first of all find out basically what these two x values here are. Okay, so I'll start with this one here. So I'm just going to set the equation, the first part of g of x equal to 19. Okay, so x minus 2 all squared equals plus 1 equals 19. Okay, subtract the 1 from both sides and square root it. I can do that in one go. So x minus 2 is equal to plus or minus root 18. Okay, and therefore x is equal to, adding the 2 to both sides, 2 plus or minus the root of 18. Now, if you just think about that for a moment, that's giving me 2 possible values where this quadratic on the left would cut the line y equals 19. Well, clearly the 2 plus root 18 would apply to this part of the curve, which doesn't exist. Okay, so we're just interested in x equals 2 minus root 18. So I'm just going to show that on the graph here. X equals minus 2 minus root 18, which is that one there. Okay, and we're now going to work on this one here, and that's going to come from where the linear part of the equation crosses the line. So we're just going to do 4x minus 7 equals 19. Okay, and if you add 7 to both sides and divide by 4, that gives you that x is 6.5 or 13 over 2. Okay, which is that value of x there. Okay, x equals 13 over 2. Okay, and for the function to be greater than 19, either x has to be bigger than 13 over 2 or x has to be less than 2 minus root 18. So it's in 2 separate parts, and so therefore I just need to say x is less than 2 minus root 18, and separately x is greater than 13 over 2. Okay, and that's how I would answer that question. and I'll just underline those two inequalities there. Okay. Now for part C, explain why H has an inverse but G does not. So let's have a look at H. Well, H appears to be exactly the same as G, or at least the first part of G. Now the reason that H has an inverse is because if we just look at this part of the quadratic where x is less than or equal to 2, then it's a one-to-one mapping, okay? Because it doesn't curve back up again and become a many-to-one mapping. So the simple answer is that H is a one-to-one mapping and G is not. Okay, so for question C, I'm just going to say H is a one-to-one mapping. Okay, which means that when you reflect it in the line y equals x, it's still a one-to-one mapping. H is a one-to-one mapping, and G is not. Okay. Now, for part D, we've got to solve an equation involving the inverse function of h being equal to negative a third. Well, the best way of doing this is just to find h of minus a third by substituting minus a third in here. It's much easier than rearranging it to find the inverse function and then setting it equal to a minus a third. So the best way, as I said, is just to find h of minus a third. So h of minus a third is simply going to be minus a third minus 2. Okay, that's minus 7 thirds squared. That's 49 ninths plus 1, which is going to be 58 ninths. And that's it. Okay. Next question. Okay, question 4. Now this one, there's a lot of information to read and take in before you start. The mathematics of this is not particularly difficult, but what is difficult is interpreting the information given and making sure you're doing the right thing with it. So take some time to read through the information and make sure you understand what's going on. We've got to write down a general equation linking y with x for this model. Okay, and it's basically a straight line relationship, a linear relationship. So all I need to do for part A is just state the equation of a straight line, and I'm just going to write y equals mx plus c. Okay, because it's of that format, and that's just one mark. Okay, now for part B, this is about proving or showing that this expression here, this equation here, is descriptive of what's going on. Now, you need to understand that 800 bars of soap were sold, okay, and they were sold at £2 each, which makes 1,600, okay, and a profit of 500 was made. So if I subtract that from that, it tells me that the cost to the factory that day was 1,100. Okay, and similarly for the other piece of information, I've got 300 bars sold at £2 each, which is 600, but I made a loss of £80. So that would actually mean that the cost of the factory that day was £680. all right? And so I can now form two simultaneous equations. Okay, and I'm going to do that now. So I'm going to say that 1100, okay, that is the y value, if you like, 1100 equals mx plus c, so m times 800, that's the number of bars of soap, plus some constant c. And I also know that 680 is m times 300, okay, plus c. Now the thing to do now is to solve those simultaneously. So if I just call them equations 1 and 2, I'm going to do it the traditional way, but you could use your calculator to save a bit of time here. And I'm just going to basically take the first one and times it by 3. So equation 1, 3 times equation 1. Okay, it's going to give me 3300 is equal to 2400m plus 3c. The second equation would be timesing by 8 would give me 5440. Yes, 5440 equals 2400 m plus 8c, and I should say that that was multiplying equation 2 by 8. Okay, and then if I subtract those from each other, I will eliminate the m term, and I will get that 2140, okay, is equal to that's going to be 5c. So from that, c is equal to a fifth of that, which is 428. And I can quickly work out from that that m is 0.84. Okay, m is 0.84. Okay, so I'm just about fitting that in there. Okay, so I now have my equation that y equals 0.84x, okay, plus 428. So that's worked out quite well and proved the result that they required us to show. Okay, so that's the first, second part of the question done. Now part C rather, all we need to say here is it's asking us about interpreting the significance of the 0.84. And what they like here is an expression or a statement like this. So basically, every time you make an extra bar of soap, it costs you another 84p. So the 0.84 means each extra bar of soap, they like that word extra in these sorts of answers. Each extra bar of soap costs 84p. Okay, you need to be careful about that. It's not a profit of 84p, it's a cost to the company of 84p for each extra bar they make, right? Okay, so that's part C. And finally, part D, assuming that each bar of soap is sold on the day it's made, find the least number of bars of soap that must be made on any given day for the factory to make a profit. Well, what I have to do here, I mean, there's lots of ways you could approach this. I mean, you could form a completely new equation linking the profits, and that would take a little bit of time and it would work. The best thing is to do this. They're saying really that the two lots, so £2 per bar times the number of bars. So I'm going to use a different variable. I'm going to use b instead of x. So 2 times the cost of a bar has to equal 0.84b, 0.84 times the number of bars, okay, plus 428. Okay, it's as simple as that. Now, if you take the, if you rearrange that, you get 1.16b, 1.16b is equal to 428. Okay, and therefore b is 428 over 1.16. Okay, and that comes to 368.9 something. Okay, and obviously it needs to be an integer, and in the context of the question, that has to be rounded up to 369 bars. Okay, and that's it. We've got to find the values of this summation here. So it's a sum to infinity of a geometric series. So we know that the formula is the sum to infinity is a over 1 minus r. So I'm just going to now evaluate that. This is for part 1. So part 1, okay. So s to infinity is equal to the first term, a over 1 minus r, where r is the common ratio. Now a is going to be the first term, which is going to be 20 times, well, when r is 4, that's the first term, so it's 20 times a half to the power of 4. Well, a half to the power of 4 is a 16th, so it's 20 over 16, which is 5 quarters. Okay, that's the first term. So s to infinity is equal to 5 quarters divided by 1 minus a half. Okay, well, that's dividing by a half, which is the same as timesing by 2. So it's 5 quarters times 2, which is 10 quarters, which is 5 halves. 2.5 or 5 over 2. All right, that's the answer. Now for part 2 of this question, what I've done is I've written out the sequence, or the series rather, term by term up to a certain point and then to the end. So it saved a bit of time. I've written it over here. So I basically take an n to be 1. So the first term is log to base 5 of 3 over 2. The next term is the log to base 5 of 4 over 3, and so on. Okay, so it's all written out here. It saves a bit of time. I've written it out. Okay, so that's what I've done on the first line there. Okay, and 5 over 4, and then 6 over 5, and so on, up to the second to last term, which would be when n is 47, I'm going to get 49 over 48, and when n is 48, I'm going to get 50 over 49. Now, if I then use the rules of logarithms, where there's a subtraction there, that's going to be log 3 minus log 2. That's going to be log 4 minus log 3, and so on. I can start cancelling out like this. Okay, so if I take, for example, the log to base 5 of 3 there, that cancels with this minus log to base 5 of 3. So they've gone. And then I've got a log to base 5 of 4 and a minus log to base 5 of 4. A log to base 5 of 5 and a minus log to base 5 of 5, and so on. This, my log to base 5 of 6 will cancel with something in there. Again, coming up to the other end, the minus log to base 5 of 49 cancels with that one. This minus log to base 5 of 48 will cancel with something in there. And in fact, I'm left simply with a minus log to base 5 of 2 and a log to base 5 of 50. Okay, well, that is the same as log to base 5 of 2, of 50 minus log to base 5 of 2, okay, which is the same as log to base 5 of 50 over 2, okay, and that's the same as log to base 5 of 25, okay, log to base 5 of 25, and of course that is exactly 2 because 5 to the power of 2 is 25. So we've answered the question by showing the cancelling out that occurs and what's left. Okay, next question. Okay, question 6. So there's lots of information here about an engineer working with braking distances and wet roads. Okay, so quite a lot to take in there, and we've got some graphs to work with, and what we've got to do first is explain how figure 4, this one here, would lead the engineer to believe that the braking distance is modelled by the formula here, okay, with k equal to that number. Well, if you look at the graph of figure 4, it's a straight line graph, okay, so it's of the form y equals mx plus c. So what we're going to do is work on the formula given here and show that it can be written as a straight line graph in the form y equals mx plus c. And this is what we do. So we start with taking logs of both sides of this. So I can say that log to base 10 of d is equal to log to base 10 of k times v to the n. Okay, so I suppose some brackets around there would make that clear. Now it's only the v that's to the power of n, not the k as well. Now if you rearrange that a little bit using the rules of logs, you can also say that that's equal to log to base 10 of k, okay, the number k, the constant, plus now it's log of v to the n, which is the same as n log to base 10 of v. Okay, so that's using the rules of logarithms there, and then I can just swap the order around slightly because I'm thinking ahead that I'm going to be looking for an equation of the form y equals mx plus c. So log to base 10 of d, okay, which is like my y coordinate, is equal to, I'm looking for the form nx plus c or mx plus c, so it's going to be n log v, because log v is the x-axis, plus my constant, which is log to base 10 of k. So basically I've just swapped those last two terms over. Okay, so it's beginning to look in the right format. Now I've got to evaluate log to base 10 of k to prove really that k is this value here, 0.017. Okay, now I know that log to base 10 of k from this graph is minus 1.77, you see, because that's the y-axis intercept. So I can say that log to base 10 of k is equal to negative 1.77, okay, which means therefore that k must be 10 to that power, okay, 10 to the power of negative 1.77, and on the calculator that comes to 0.017 to two significant figures, which is the value given in the question. Okay, so I can just conclude that by saying that log to base 10 of k is equal to log to base 10 of d rather, log to base 10 of d, that's the y coordinate, is equal to n times the log to base 10 of v plus this number here, which is, well, it's log to base 10 of k I want there, which is minus 1.77. Okay. So, and that's of the form y equals mx plus c. So I'm just going to put that in sort of speech marks really, because I'm not actually using the letters y equals mx plus c, but I'm just showing that it's in the form of a straight line graph. Okay, now for question B, I have to find a complete equation for the model giving the value of n to 3 significant figures. So for this I use some of the information provided on figure 3. So I can say that when v equals 30, I know that d equals 20. Okay, and from that information I can include that, or conclude rather, that log to base 10 of 20 equals n log to base 10 of 30. Okay, just by substituting those values in, minus 1.77. Okay, and then I can just rearrange that to find n, which is going to be equal to log to base 10 of 20. And I've got to add on to that 1.77 and divide the whole thing by log to base 10 of 30. Okay, and put that on the calculator. And it tells me that n is equal to 2.08 to 3 significant figures. Okay. So the equation in this form becomes d equals 0.017v, 0.017v to the power of 2.08. Okay, so just write very clearly which is the power, make it clear that it's raised up there and it's easy to read. Okay, so that's the second part of the question done. Now, the last part is saying use your formula to find if Sean will be able to stop before reaching a puddle that is 100 meters ahead. So what I'm going to do here is I'm going to recognize that there are two parts to this. First of all, I need to look at the distance that the car traveled during the braking, and also the distance it traveled before Sean reacted. Okay, so there's two parts to it. So the total distance is going to be made of the formula, which we've already established. Okay, 0.017 times 60 to the power of 2.08. Okay, plus the reaction time. Now, if you're traveling 60 kilometers, that's 60,000 meters. But you want to do that in seconds, probably. So 60,000 over 60 times 60. Okay, or 3,600. That's converting it to meters per second. And then you need to times that by the time, which is 0.8. Okay, because distance is speed times time. And that part there comes to 13.33 recurring meters. Okay. And this part here comes to about 84.9. When you combine all that together, you get 98.25 to 4 significant figures, 98.25 meters, okay, to 4 significant figures. Okay, and I'm just going to say that that's less than 100. Okay, and my conclusion is therefore Sean does stop in time. Sean does stop in time. Okay, not by much. I mean, he's got 1 meter and 3/4 left, but nevertheless he stops in time. Okay, so that concludes that question. Number 7, a vectors question. Okay, lots of information here. Add it to the diagram, okay, as you read through it. So OC is 2 lots of OA. So I'm just going to create point C in the right place, twice as far away from O as A is. Okay, so that's going to be my point C up there somewhere. Okay, and then I've got this line that goes through the midpoint of AB, okay, which they're calling M, and the line goes through C and M and joins the other line OB at the point N. So if I put that in there like that, I can now add N to my diagram. Okay, and I can label some vectors on here. Okay, that vector there is going to be the vector little a. OA is A, and because AC because OC is double that, I can also label this vector here as A as well. Okay, now I could label the vector OB as little b, but the trouble is if I put it on the line there, it's then confusing as to whether B means O to N or O to B. So I'll just leave that off for the moment and see how we get on. Okay, so the next thing is that I need to work out, first of all, CM in terms of A and B, okay, in terms of lowercase a and b. So the vector that joins the point C to M, okay, so what I'm going to do is make a journey that takes me from C to M, and the way I'm going to do that is to go first from C to A, and then from A to M. So I write it out in that form first using the capital letters, and then I'm going to convert that into the lowercase vector form. So C to A is the negative of A. I can see that clearly from the diagram. And then I've got half of B minus A. Okay. Okay, because the vector B minus A, little b minus little a, is how you travel from A to B, and I want half of that. So it's a half of brackets B minus A. Okay, and when I just multiply that out and simplify it, it gives me negative 3/2 times A plus a half B. Okay, so that's CM in terms of A and B. Okay, now part B. Okay, now in this question here, I am asked to show that ON is equivalent to this vector expression here. So what I'm going to do first is write down that ON can be achieved by going first of all O to C, which I know is 2 lots of A, and then some multiple of what I've just worked out, some multiple of Cm, which I'm going to call lambda times Cm. Okay, and I'm now going to convert that into lowercase form. So that's 2 lots of little a plus lambda times this thing I did here, minus 3 over 2a plus a half b. Okay, now if I process that, expand it out, that gives me 2a minus 3 over 2 lambda a. Okay, and it also gives me plus a half lambda b. And if I regroup everything together, the a parts and the b parts, it does indeed give me the expression above that I needed to show. So 3 over 2 lambda, that's the coefficient of the vector a, plus a half lambda b. As required, because I was required to show that statement. Okay. Now for part C, this is an interesting little part to the question, because you've got to prove that ON to NB is in the ratio 2 to 1. Okay, so I'm going to do it like this. I'm going to start by writing down that ON plus NB is little b. Okay, so ON plus NB is the same as the vector lowercase b, which is the vector from O to B. Okay, now I'm just going to do a sort of subtraction. I'm going to just start with B and subtract the vector ON from it. Okay, and the vector ON I've just found to be this thing here, okay, with the yellow line under it. In fact, what I'm going to do is take a copy of that, if I can. Let's see if I can achieve that without getting the yellow line in it too. I think that's it, and it will save me writing it all out again. So it's b minus all of that, but of course I need to be careful because that will need a square bracket around it or something, just to make sure that I don't make a sign error. Okay, so that's b minus the vector ON, and that must equal NB, you see. Now, what we need to recognize here is that at the moment that contains some components of the vector A in it. Okay, if I just take out the brackets and multiply that out, I'll go to the next stage. So from that I would get that NB is equal to, well, I could just change that into an equal sign at that point. So NB, which is equal to B, okay, minus 2 negative 3 over 2 lambda, lots of A, okay, and then minus a half lambda B. So all I've done is remove those large square brackets. The reason I'm done that, just to make this clear, is if NB is clearly a multiple of B, then any A component must be 0. Okay, so I can therefore conclude from that if NB equals that, it implies that 2 minus 3 over 2 lambda must be 0. Okay, because you can't have any component of A in the vector NB, because it's purely parallel to the vector B. So that must equal 0. And if you just work that out, it means that lambda has to be 4/3. Okay? And once I know what lambda is, which I now do, I can use that in solving the rest of the problem. So this term here is 0. So I'm left with NB equals B. So NB equals the vector lowercase b. This is 0 minus a half of 4/3 times b minus a half of lambda, which we know to be 4/3 of b, and that is equal to, well, half of 4/3 is 4/6, which is 2/3, so it's MB is 1/3 of B. Okay, which looks about right on the diagram. Therefore, ON must be 2/3 of B. Okay, and then I've got my ratio. ON is 2/3 of B. So ON to NB, so ON to NB equals 1/3 to 2/3. Sorry, 2/3 to 1/3, I should say. 2/3 to 1/3, which is, of course, 2 to 1 as required. Okay, just about fitted all of that into the space given there. Okay, so quite an interesting little question, that one. Okay, next one. Now this is about being very careful with your algebra to show that this particular expression is representative of the surface area of this tank. Okay, so for question, I'm going to use the fact that the volume of the tank is 9 meters cubed, and I'm going to write an expression for the volume. And the volume is a hemisphere, okay, which has a volume of 2/3 of pi r cubed. So it's 2/3 pi r cubed. All right, that's the hemisphere at the top, plus the volume of the cylinder, which is pi r squared times the height, which is h, and that equals 9. Okay, so rearranging that, I can have that pi r squared times 2/3 r plus h okay, and that must equal 9. So I'm trying to get an expression for h, and I can get that by rearranging that into h equals 9 over pi r squared minus 2/3 r. Okay. You see, the clue there is that I'm looking for an expression here that doesn't contain h. So I'm going to have to restate h in terms of r, which I have now done, and I can incorporate that in the equation I get for the surface area. So the surface area, that's based on the volume. So I can now say that the surface area, I'll just use SA as an abbreviation, the surface area is equal to the area of the circular base of the tank, which is pi r squared, plus the curved surface area of the hemisphere at the top, which is half of 4 pi r squared, in other words 2 pi r squared, plus 2 pi rh, which is the surface area of the outside of the cylinder, 2 pi rh. Okay, but I know that 2 pi rh is 2 pi r times this expression I've just got here. Okay, so that can now be written as in total 3 lots of pi r squared plus 2 pi r times my expression here, which I'm just going to copy, if I can pick it up from there. Okay, and 2 pi r times that, I'll just put that in a bracket, and now I have an expression, you see, for surface area, which is entirely in terms of r, and I've just got to rearrange that to show that it's equal to that expression that they give us here. Well, a couple of steps will take me to that, so I think that comes to 3 pi r squared plus multiplying out the brackets, 18 pi r over pi r squared. Okay, 18 pi r over pi r squared, and also I have minus 4 pi r squared over 3. Okay, you can check all this out for yourself, but it works out 4 pi r squared over 3. And if you simplify that further, you will indeed end up with 5/3 of pi r squared. Okay, 5/3 of pi r squared and plus 18 over r. Okay, now it's important when you do something like this not to miss out too many steps, because it is a question where you're asked to show that something is true. Okay, but there's sufficient enough in there to show that you know what you're doing. Okay, in part B, I've got to use calculus to find the radius of the tank, causing the surface area to be a minimum. So I need to differentiate this expression for the surface area. Okay, so I'm going to do that here. Okay, so the first thing is to state what I'm doing, which is to find the derivative with respect to r of this expression here, which I can just copy and take across. Okay, now if I differentiate that, I'll need to put some brackets around that. Okay, so I'm differentiating that, and that will give me 10 pi r over 3. And it will also give me 18 over r squared minus, okay, because I'm differentiating 18r to the power of minus 1. Okay, so the minus comes in front, the power drops to minus 2, and that's what you end up with. Okay, so that's an expression for the derivative, and that has to be equal to 0 when it's a minimum or maximum. So I now have to solve that equation. Well, if I multiply everything by 3r squared, that's going to give me that I'm going to get 10 pi r cubed is equal to 54. Okay, then I'm going to get r cubed is 54 over 10 pi. Okay, so r cubed is 54 over 10 pi, which is of course 27 over 5 pi. And what I'm just going to do now is write that as a cube root. So r, the radius, when the tank is at a maximum or minimum, and we can assume from the question it's a minimum. We're not required to prove that either. So if we just go to r equals the cube root of that, or of course another way of expressing that is to put 27 over 5 pi to the power of 1/3. Okay, and that's how I'm going to express the value of r. It doesn't need it in a decimal form. It doesn't ask for that, so that will answer part B of the question. Okay, now for part C, I have to now use that value of r to calculate what the minimum surface area of the tank is to the nearest integer. Now I'm going to move this up, so we're going to lose the first part of the question, but that should give us enough space to work with. Okay, and we can do that here. So for part C then, okay, here, we just have to substitute this value of r into our expression for the surface area. So we have 5 pi, okay, 5 pi over 3, and that has to be times by the square of this. Well, the best way of doing that is just to write it as 27 over 5 pi, okay, and instead of to the power of 1/3, we just put it to the power of 2/3. Okay, just using the indices rules. Make sure that power is smaller and up in the air. Okay, so it's clearly a power. And then we've got to add onto that 18 over r. Okay, and that of course is the same as doing 18 times r to the power of -1. Okay, which is the same as doing 18 times 27 over 5 pi. Okay, now instead of to the power of 1/3, it's going to be to the power of -1/3. Okay, and if you put that into your calculator, it comes to 15.026. And the question requires it to be to the nearest integer, so it's 15 meters squared to nearest integer, or to two significant figures. Okay, so that's the answer to part C. Next, okay, partial fractions, and then leading into a question about binomial expansion. Now, with a question like this, where we have an improper algebraic fraction, okay, that means the numerator is of a higher power or the same power as the denominator. There's several ways you can approach this, but the best way, I think, in this case is just to make a common denominator of this throughout and just compare the numerators. That's exactly what I'm going to do. So my approach to this would be for part A, okay, I would simply write down that A times 2x plus 1 times x minus 1, okay, plus B times x minus 1, and then I would have C times 2x plus 1, And all of that is effectively the numerator of this fraction over 2x plus 1x minus 1. So I just need to compare that with the numerator of the algebraic expression we're given, which is 4x squared minus 4x minus 9. Okay, 4x squared minus 4x minus 9. And my next approach would be to work out values of a, b and c as efficiently as I can. Well, you see, b and c are not going to link to any x squared terms. So the only x squared term is going to come from a times 2x times x. So I can say that 2a times x squared, okay, must be equal to, equating coefficients to the other side, 4x squared, okay? And if that's true, then I can see straight away that a must be the number 2. So I've already got one of my 3 variables. Okay, and now what I'm going to do is I'm going to make some substitutions. I'm going to substitute x equals 1, okay, into this expression here, because if I do that, it means this term will be 0 because of the x minus 1, this term will be 0, and I'm just left with c, okay, times 2 1s plus 1, so it's c times 2 times 1 plus 1, okay, is equal to 4 times 1 squared, which is 4. I'm showing the full substitution here. 4 times 1 squared minus 4 times 1. Okay, minus 9. And if I just work that out, that's 3c equals, okay, so I've got 3c, and that equals, well, that's 4 minus 4 is 0, minus 9. 3c is minus 9. Okay, so therefore c must equal minus 3. That's the second value found. And now if I substitute x equals negative a half into the first line, it will cause that one and that one to be 0, and I can therefore see that b times negative a half, negative 1, so b times negative a half minus 1 is going to be equal to 4 times a half squared, which is 4 times, well, minus a half squared, which is 4 times a quarter, okay, minus 4 times minus a half, okay, and minus 9. And working on that gives me that negative 3 over 2b is equal to negative 6, and therefore negative 3b is negative 12 and b is 4. Okay, so it doesn't actually take very long using that method, quite often anyway. So I have found the values of b, a and c as required in the question. Okay. Now for part B, I've got to use my partial fractions to make an expansion of this using the binomial expansion as far as the x squared term. Okay, so to save me writing all this down every time, I'm just going to call this function here f of x. So that saves me writing the whole thing down each time. Okay, so I can now say for part B that f of x can be expressed in partial fractions as follows. Okay, so b f of x is the same as 2, that's the a, and then it's going to be plus 4 over 2x plus 1, but I'm going to write that as 4 times 2x plus 1 to the power of minus 1, and then it's going to be minus 3 times x minus 1 to the power of minus 1. Okay, and that's going to help me set it up for the binomial expansion. Now, what we need to do here is just make an adjustment, because we want these brackets to be in the form 1 plus kx for some constant k. So the first one is easy, so that's going to be 2 plus 4 lots of, and all I need to do is reverse the two terms, so it's 1 plus 2x, okay, to the power of minus 1. So that hasn't really changed anything apart from swapping the terms over. However, this one, just to be very thorough about this, what I'm really doing here is I'm doing minus 3 times, now you need to be very careful about the use of brackets here, so I'm going to change this to 1 minus x, which means I've got to multiply it by minus 1. So it's minus 1 times 1 minus x. Okay, sorry, 1 minus 1 times 1 minus x, like that. Okay, and all of that bracket is to the power of minus 1. Okay, now the minus 1 to the power of minus 1 is 1 over minus 1, which is minus 1. So it means I can take the minus 1 outside, and that then becomes a plus. So what that actually leaves me with is 2 plus 4 lots of 1 plus 2x to the power of minus 1 plus 3 times 1 minus x to the power of minus 1. Okay, you just have to be careful, because you see, if you'd missed that sign change there and you'd put minus here, the whole thing would go wrong. So you just have to be very careful when you're making these adjustments. So that's what I'm actually going to be working with here. So if I go on to the next line, I can say that f of x equals, let's do it on the line immediately below to save some space. So f of x equals 2. Okay, so I'm working on this now. Now it's going to be plus 4 lots of, and the expansion up to the x squared term is going to be 1 plus, okay, and then I need to do minus 1 times 2x, okay, and then I've got minus 1 times minus 2, so it's n minus 1, n minus 2, or rather n minus 1 I should say, and then it's 2x squared, all squared that is, over 2 factorial. Okay, let me just put my fraction line in there. And then, of course, we know it carries on after that, but we don't need to go any further. So I'm just going to put plus dot dot dot. And then we've got to do our 3 lots of the expansion for 1 minus x, which is going to be 1. So let me put my square brackets in. 1 plus minus 1 times minus x, and then it's going to be plus minus 1 times minus 2 times the square of minus x, okay, all over 2 factorial, okay, Now I'm being very careful to put all the steps in here because it's so easy if you try and carry some of this in your head just to make a sign error. And once you've made one sign error anywhere in this, you've got it wrong at the end and you've lost some marks. So it's worth taking great care each step to write everything down in full, step by step. Okay, it's worth 6 marks, so you're expected to spend a bit of time. Now, if we take that to the next stage, that comes to what have we got here? We've got f of x now is equal to 2 plus 4 lots of 1 minus 2x plus 4x squared. Okay, plus 3 lots of, from this second part here, that gives us 3 lots of 1 plus x squared. Okay, so quite a lot of work to do with these questions, and they do take some time. And that's what I've got, and it's just now a question of tidying all of that up. I'm just going to move this up to give me some more space. Okay, so that now can be written as 2, well, I'll go straight, I'll miss out one step here and just go straight to the final result, which is 9 minus 5x plus 19x squared. Okay, you could do the same, I'm sure, but just be very careful. Okay, so that's the expansion up to and including the term in x squared, and for part C we've just got to explain why it's not valid for x equals 3/4. And it's invalid for just one part of the expansion, and that is 1 plus 2x to the minus 1. Okay, so I'm going to say it's invalid for that part. Okay, invalid for 1 plus 2x to the minus 1. Okay, and the reason for that is that the bit you're squaring and cubing, you see, is 2x. And if x is 3/4, then 2x is 1.5. And because it's greater than 1, you are going to get something that's diverging. So I'm just going to say it's invalid for that since, okay, 2 times 3/4 to the n, in other words, 1.5 to the n, so 2 times 3/4 to the n, okay, equals 3 over 2 to the n, which approaches infinity as n approaches infinity. Okay, so I made it very clear that I know that the series is diverging. Okay, so that's it. And last question. And it says in this you must show all stages of your working, and if you just rely on the calculator you won't get all the marks. So the first thing is a classic proof of the sum of a geometric series. So what we do is we have to set out that let S be the series, let's start it just here. So S equals a geometric series with a first term of A and a common ratio of R. So the first term is A, second term is AR, third term is AR squared, and the fourth term is AR cubed, and so on. Okay, and then the second to last term is AR to the n minus 2, and the final term is AR to the n minus 1. Okay, because the first term was effectively AR to the power of 0, you see, that's AR to the power 1, and so on, right? Now, we then take the whole series and multiply it by R. So R times S basically means we take each term and increase it by, or multiply it by R. So that becomes AR plus AR squared plus AR cubed, okay, and so on, plus AR to the 4, and then the last two terms of that series would then be AR to the n minus 1 and AR to the n. Okay, and now we subtract. Okay, and I can do it in either way, it doesn't really matter. I'm going to do, looking at the way it's set up there, I'm going to do the first one, take away the second one. So S minus RS, okay, is going to equal this minus this. Well, the ARs will cancel, and you can see there's a whole string of cancelling that goes on here. So the ARs cancel out, the AR squareds cancel out, the AR cubes cancel out, the AR4 will cancel out with something there. The AR to the n minus 2 will have cancelled out with something there. Those two cancel out, and you're just left with A and AR to the n. Okay, so I just go to here and say that this is equal to A minus AR to the n. Okay, now I can factorize out here an S, so I can say that S times 1 minus R is equal to A times 1 minus R to the n. Okay, factorizing out the A from the right hand side, and therefore if I divide both sides by 1 minus R, then I get S equals A times 1 minus R to the n over 1 minus R. And that's exactly the result that I was required to prove. Okay, so sometimes write afterwards QED or as required, or something to that effect, just to show that you've finished your working. Okay, so we've then got to do this question concerning a geometric series that S8 is 7 times S4. Okay, now what I'm going to do, and we've got to find the exact value of R. So this is what we're going to do here. Okay, now I'm just looking for the best space to work in. I'm going to move this up, and I can go up as far as that, I think, because we have our result that we need there. Okay, so here we go. So if S8 is equal to 7 times S4, then I can say that for part B, all right, S8, so just make an opening statement, S8 equals 7 S4, okay, and that implies that A times 1 minus R to the 8 over 1 minus R is equal to 7 times A 1 minus R to the 4 over 1 minus R. Okay, and that's directly using the result we've just proved. Okay, so that's my opening statement. Now, if I just, I mean, there's going to be loads of cancelling to do, but I'll just do it step by step. So if we cross multiply, I can immediately lose the 1 minus r's, and I can say that 7a times 1 minus r to the 4 is, or well, I just look at the denominators. A 1 minus r to the 8 equals 7a 1 minus r to the 4. Okay, now I can of course, remove the a's, and I've got 7, I've got 1 minus r to the 8 equals, let me write that down underneath, 1 minus r to the 8 is equal to 7 lots of that, or 7 minus 7r to the 4. Okay, now I'm going to make a substitution now. I'm going to say let k equal, you don't have to do this, but it makes it a bit easier to see what's happening. I'm going to say let k equal r to the 4, because what I'm doing here is recognizing that I have a quadratic in r to the 4. Okay, so that means that from here, okay, I can say that r to the 8 minus 7r to the 4 plus 6 equals 0. Okay, if I just rearrange that and multiply everything by -1, I get that, you see. So what I'm saying is I'm going to let r to the 4 equal k. So this implies that k squared minus 7k plus 6 equals 0. Solve that quadratic, and I get a factorization, k minus 1 and k minus 6. So k minus 1 and k minus 6 equals 0. Therefore, k equals 1 or k equals 6. Okay, which means that r to the 4 equals 1, or r to the 4 equals 6. Now, it says at the beginning that in the question it said that r cannot equal 1. All right, and of course it can't, because if r does equal 1, then your common ratio is 1. All your terms in the sequence, all your terms would be the same. Okay, because if you're just multiplying by 1 each time. So we just need to note that that's an invalid solution. Okay, because it says r cannot equal 1 in the question. All right, but this one means that r equals the 4th root of 6, which is 6 to the power of 1/4. Okay, and that's the answer to the question. And that's the end of the paper.